2024, without question, is the year of AI and the year of every company claiming that they do AI. And occasionally we get some incredible surprises. Generally, when we think about leaders in open LLMs, we think about big tech companies like Meta or companies like Mistral AI. And we've gotten certain surprises before. For instance, when Salesforce released an AI model, where in theory they were automating salespeople. So today, a company called Databricks released an absolutely incredible general purpose LLM that I'm willing to say is the next state of the art and the benchmark for the most performant and impressive open large language models we've seen ever. And this is surprising, but also not surprising, because Databricks is a data-driven company. They've been doing data engineering for basically the last 5 years, and it makes sense that just given their engineering nomenclature and the way they run their company, that now they're doing tons of AI stuff. So the model I want to talk about today is called DBRX, and it's completely insane. So why is this model so impressive? What are its actual capabilities and technical breakdown? Is it better than Gemini 1.5 and a bunch of other leading edge open source models we've seen? And can you use it right now? I want to get into all of these topics in this video. Welcome to AI Flux. Let's get into it. So for those of you who are curious what DBRX stands for, it's basically just an acronym that's supposed to sound like Databricks. And again, Databricks is a pretty interesting company. Beforehand, it was just another sort of another bland cloud data engineering company in SF that started to do some interesting work about 2 years ago. And today they released DBRX, which is a 16 by 12B mixture of experts model trained on a stunning 12 trillion tokens, which is kind of insane. And what's really interesting is what this model actually does with all of those parameters and how it actually manages to outperform a bunch of incumbent open LLM competitors. So the breakdown of DBRX is pretty interesting. We have 16 experts, 12 billion parameters per single expert. Its routing is based on generally top K4. It has 36 billion active parameters, which is basically what's being applied to look at any given token flowing in. It has in total 132 billion total parameters trained from 12 trillion tokens. And like the recent Mistral AI 7b release at the Mistral Hackathon, has a 32,000 token sequence length training, which is kind of interesting. So the mixture of experts model produces a model that has 132 billion total parameters of capacity, but again, it only uses 36 billion parameters to process each token. DBRX handily outperforms models such as LLaMA2-70b and Grok while being more efficient, and part of this is just what it's doing with its massive parameter count. Grok was impressive at the time, however, one thing it wasn't great at was being efficient, which is why in certain cases, Mistral 7b fine-tunes would handily outperform Grok in a number of tasks. Although when Grok was just being developed, in theory it was still state-of-the-art. What I would call DBRX is kind of a fine-grained MOE architecture, which is really what leads to all these incredible efficiency gains. And what this means in terms of efficiency and what these gains are is a 2 times faster inference ability when compared to LLaMA2-70b, while also being around 40% smaller than Grok in total active parameter counts. And one thing that I think is interesting that should be talked about more with these models is, total parameter count is interesting, but active parameter count is really what shows how well these models use those parameters they're trained on. And again, a trend that keeps emerging is just brute forcing against more and more parameters and even more just total tokens trained on does not necessarily always lead to better performance. In certain cases, it actually does the opposite. And when it comes to open source models, there are two sides of the coin to this win, because it means, one, you're making a model that's more capable. It means you're just getting more usable utility and capability out of the model itself. And if the model is smaller, it just means that more people can actually use it. There were valid criticisms of Grok when it initially came out, which was, if you're releasing these massive models, and Stability AI has also seen similar criticism, which is if the model is so big and you're spending all this money on GPU time to train it, if less than 10% of your potential customer base can even run it on their own GPU or even afford to rent enough GPUs to run it, then what's the actual point? This gets really interesting when you start to see that DBRX has actually already been quantized to run on MLX, which is insane. And part of the reason this has happened so quickly is because it's so efficient, and because even when you quantize it, these efficiency gains and capabilities don't necessarily go away as much as you would think. But we're going to get into that a bit more just a bit later. What's also crazy is it surpasses GPT 3.5 and competes with Gemini 1.0 Pro and Mistral Medium in quality, while also being substantially faster. And again, by substantially faster, I mean about twice as fast. And this is without using some crazy LPU inference layer like Grok has employed. One thing that will be wild is to see if Grok, the company that builds LPUs, actually has enough of them to deploy models like DBRX on. That would be completely insane. What's also pretty cool is the 32K sequence length training makes a state-of-the-art RAG model completely possible, almost out of the box. DBRX outperforms the best open source models and even outperforms GPT 3.5 Turbo in this area. And frankly, this isn't that surprising because in theory, the products that Databricks has been trying to build for years are effectively all RAG. The reason you would go to a company like Databricks is if you say you were a company like Amazon, but maybe didn't have an internal kind of development team, and you said, I have all this data and I want to understand what I can do with it, or I want to put all this data into one kind of data lake in the cloud, and then I want to present it in a way to, say, salespeople or consultants so they can actually do something with it. And this is why it's not surprising that data engineering and sort of cloud-first data engineering companies like Databricks, and to a certain extent companies like Salesforce, are now pivoting so heavily into AI and are creating amazing things. And also, it's not that surprising because although ChatGPT4 largely has replaced the lion's share of data engineers and data scientists, the most capable cohort of those developers are basically the best bang for your buck when it comes to fine-tuning and developing new AI technologies like this on top of existing platforms. They're not exactly researchers, which obviously companies like OpenAI and Anthropic have a massive stronghold on. Like, the research talent is clearly there, but it's also the most expensive. So what's interesting is we're seeing massive wins from companies like this because they already have a lot of developer mindshare that can easily pivot to develop generative AI and sort of LLM-like things. And clearly they'd understand how to derive value because what they've been doing for the last 5 years was taking in data, using it to create value, and now they just have better tools to do that. And a lot of them are open source. And clearly they realize the value of open sourcing this stuff because then you get a much better just return on mindshare and return on potential things that your developer team couldn't even think of. And Databricks employs thousands of engineers. So this is really, really cool to see. And what's curious is the blog post from Databricks reveals some pretty interesting benchmarks. So I know I've told you that in theory the inference speed is twice as fast and that it competes well with Mistral, Grok-1, and a few other models, but by how much? So what's also cool is they mentioned some things about how much compute it took to train these models. So what's interesting is DBRX, although it's basically 1% more capable in MMLU than Grok, took about 4 times less compute to train, which is more important even just outside of the environmental considerations and just how much power you have. What that means is that if you have a data center, right, you can use 1/4 of the GPU time to do this. It means you can have more GPUs that you're selling to more people for inference. And 2x inference means you can basically make 2x off of every GPU you're renting out to people to make API calls. And an area where it completely destroys the competition is in programming and math. And curiously, Grok was actually very, very capable here. Substantially more capable than Mistral from Mistral AI. And we're seeing nearly a 7% performance boost with DBRX when compared to Grok, while still maintaining 2x the inference speed, and also with math based on GSM 8K. Again, there's about a 4% boost, which is significant in this area of systems. Obviously, we haven't seen Llama 3 from Meta yet, and hopefully we see that within the next few weeks, if not before midsummer. But I'm really eager to see where that works out because obviously Databricks is a tech company, but with Twitter and Meta, they have really massive internal data sets for programming. So you would think that they would really have a massive gain here. And LLaMA2-70b is just about a year old at this point, and it's wild to think that we're seeing such massive improvements from LLaMA2-70b. Now, granted, clearly this is not to scale, right? Because 32% to 63% is not like a 10x multiple. So they're juicing the graphs a little bit here, and we have to give them a little bit of a hard time since they're a data science company, and you'd think they'd know how to realistically scale graphs, but I'll give them some credit because this model is actually pretty impressive. And I want to get into some of the details of what DBRX actually is. So it's still transformer-based, it's a mixture of experts model, and what's really interesting is it actually uses the GPT4 tokenizer as provided in TikToken, which is kind of interesting. And in theory, this was also built with a bunch of exhaustive evaluation about scaling. So more of the impetus here was, how can we continue to scale and still see reasonable improvement as opposed to just scaling just for the fact of hoping something good happens? They also used quite a bit of pre-training using the MPT family of models, which is pretty cool. There are also a lot of tools that were used that actually were developed by Unity, which is kind of interesting. And again, the reason this is so good is because Databricks is a data science company and they work with data at scale, and they've been doing it for 10 years. So obviously, it's curious that they used Apache Spark to do some of this. It's basically a massively distributed database, which is kind of interesting. And what they say here is that they used a curriculum of learning from pre-training, changing the data mix during training in ways we found to substantially improve model quality. So clearly they had some very interesting secret sauce going on to make this improve as fast as it did. And they're also big mentioning that quality on benchmarks is a really important factor, noting that, composite benchmarks are probably the future going forward, especially when we look at benchmarks like the Hugging Face Open LLM leaderboard, which is one that I use quite exhaustively. And ironically, of course, they have their own benchmark called the Databricks Model Gauntlet, which is a suite of over 30 tasks that are constantly changing, spanning 6 different categories. And they use that to kind of garner their ways of measuring these models too. And what's important is having these be accurate and non-biased is actually more valuable than just having your model perform well on Twitter. The importance here is that, if you're using it as immediate feedback to understand if changes you're making are actually better, removing bias from these benchmarks is actually very important. So one of the first models you can use right now is called DBRX Instruct, and unfortunately you have to request access. So I've requested access and hopefully they grant it to me. I'm sure someone's going to just put this up on Hugging Face eventually, but right now they are slightly limiting who can actually mess with this model. What's available right now is called DBRX Instruct. What's cool is they've actually left in the ChatML tokens, so you can use this just as you would interact with any other kind of raw model with ChatML syntax, which is kind of interesting. And I'll link to this blog post in the description below. Another thing that's kind of interesting here is they beg the question of, why are certain open models so much better than closed models? One of the best closed models in existence right now being Cloud 3. So good, in fact, that Anthropic can barely afford to keep it running on GPUs that they're renting out, and it's already the most expensive inference API in existence. I will say that it looks like a lot of these benchmarks were done before Gemini 1.5 was generally available, or maybe they've just cherry-picked this because Gemini 1.5 is actually performing better in certain areas. Granted, even if it was, this is open source and Gemini 1.5 isn't, so that's kind of interesting. There is, again, a massive focus on long context tasks and RAG. I wouldn't be entirely honest if I didn't think that Mistral releasing their sort of subversion of Mistral 7b v0.2 base a week ago didn't have anything to do with maybe rumblings of this model, especially given the fact that they both have a 32K token context window. And I think some of the most interesting benchmarks and sort of fine-tuning I'm looking forward to is Mistral 7b compared to this model. So again, training efficiency was pretty good, and this gets into who can actually run this model right now. So even though this model already comes built in with NVIDIA Tensor RT efficiency improvements, what's interesting is you would need a ton of RAM, like a metric ton of RAM, to actually run this. So if you want to run this model right now, you would need a shocking 264 gigs of VRAM, and probably an equivalent at least 264 gigs of system RAM as well, which is interesting because you actually have to track parameter count and a number of other things. And curiously, when models get this big, you actually need a pretty beefy computer or server in its own right to run them. What I will say is, I think we need better metrics to understand how hard models are to run on hardware, because what's interesting is depending on what kind of quantization you're using and what kind of precision you're working with, it can be kind of misleading. Because, for example, a 7 billion parameter model using float 32s will almost certainly outperform a 7 billion parameter model using float 4s, which is to say there is still a value if you have the money to run these models in their full size on a massive server that might, it might cost $15 a minute to run, but in theory, you will get better results out. Now, obviously, I'm also in the camp that would argue that Q5 quantizations perform generally on par with most base models, but it's been a while since we've seen a architecture like this using 12 different experts and using so many parameters per token in a general way. But again, this has already been quantized to run on an M2 Ultra Apple Silicon chip, which we are going to cover in a different video. So the absolute bare minimum you would generally need to run this model in its roughly quantized form is about 80 gigs of VRAM, which I think is pretty cool, and hopefully we'll see that soon publicly. I have a friend working on this, and with a very recent addition of a channel sponsor that has to do with a lot of GPUs that I'll be talking about very, very soon, I think I'll be able to rent as many GPUs as I need. So I'm very excited to get into that and show you guys. Another thing that's interesting with this model, although it's much better at coding, it proves that all LLM models converge to a certain point right now when trained on the same data. So for instance, there's not a lot of differentiation between one model or the other once you're above a certain trillion token count that you're training on top of. Claims about outperformance on tasks are just that, they're claims, and of course, what you're going to do with these models and what Databricks benchmarked, or what these benchmarks like GSM-8K benchmark, all vary to an extent. So you still need to use the model to understand if the performance is really there, and obviously performance varies based on who's using it and what they're using it for. And the great thing with this being open source is you can fine-tune it further for exactly what you need in the case that it generally isn't capable right out of the box. And I know some of you guys watch these videos for my half-baked business analysis, and I think this is a really important thing to mention with this model coming from a company like Databricks. So some people ask, why do these companies, especially with Stability AI's CEO departing and people questioning how on earth they're going to make money, people are really curious, like what is the business benefit Databricks and companies like this get by spending millions of dollars on an open LLM they're really just kind of giving away, and that you just have to provide an email and what you're going to use it for, and then you get full access. What's interesting is Silicon Valley works in really illustrious, sometimes weird ways. And the goal here is to always drive enterprise business towards consumption. With AI, they need to desperately steer the narrative away from API-based services like OpenAI, which clearly are kind of starting to flounder. And by training LLMs, they build sales artifacts, which are stories, references, accelerators with LLMs themselves. And these all paint pictures that you need to convince enterprise customers that Databricks is the platform for enterprise AI and not OpenAI. So it's kind of adding more polish. It's saying AI is the future. Here are more examples. And that's why they're so focused on RAG, or basically a version of chat with PDF or dump information into it and chat with it on more steroids than Andrew Huberman takes. What's also cool is with open source, the win is you can show that most anyone can do it, that you don't need to hire a team of consultants or a team at Databricks to do it for you. The reason they do this is they show that you can do it yourself with a limited level of investment and then still commit to AI based on a platform that is still effectively built by Databricks. So kind of similar to the Red Hat model and Enterprise Linux, which I don't fully agree with, but if you know what I'm talking about, you get what I mean. Using Spark for training is also super cool. This is another great example of an enterprise product that is also open source, which is really cool to see. Although I should mention that Mosaic AI has also used a really similar architecture. And in this day and age, I don't think Mosaic is talked about enough for really wild architecture choices they made back in 2023. And in theory, I've been talking to a friend that's been quantizing this already, and I think we're probably going to see a version of this you can likely fit onto a 3090. It will be pretty cut down, and obviously quantized versions of Mixtral were also quite reduced in their ability. But I do think we're going to see some really wild things coming out with this that will let everyone use these models. And ironically, with this many experts, you're probably actually going to the first time have CPU bottlenecks and system RAM bottlenecks, even if you have like 6 3090s. So I say 3090s, but I really only mean one expert per 3090. And in my second video, I'm going to go over the system prompt that's already been released and extracted, which I think gives some other really interesting insights. So I'm curious what you guys think. Are you going to try to quantize this and run it on MLX? Are you hoping someone's going to quantize it so you can run it locally? Do you think this is actually better than Mixtral and better than Grok-1? Do you think Grok-1 from Elon Musk was like a total waste and just kind of a marketing farce? Let me know in the comments below. If I missed anything or you want me to go into more detail, also let me know in the comments. So, as always, I hope you learned something in this video. If you like this video, please like, subscribe, and share, and we'll see you in the next one.